first of all, I want to say welcome to everyone for attending our follow-up salon after Carlo Rovelli's excellent talk yesterday, discussing the intricacies of causes and effects. And so today we're going to have sort of a moderated discussion with an open Q&A at the end of it. And it is my absolute pleasure to introduce to you the interlocutor for today, and that is Eric Winsberg, who is a philosopher of science and works on philosophy of physics a lot, and has worked in particular on models, inferences, drawing inferences from modeling and conceptual frameworks. He's an expert and he's looked at many kinds of models. So he's extremely well known for his work on the nature of simulations and numerical simulations, with applications particularly to one of the most vexing problems of our times, which is the climate problem. So the modeling of climate and what the issues are with modeling a complex system like that, which is a nonlinear complex system. So that is sort of his expertise. And in general, as I mentioned, he looks at conceptual frameworks. And currently he is looking at COVID-19. And isn't that right, Eric? So you're—
Yeah, I've been looking at some of the modeling stuff with COVID-19,
right.
Yeah.
And of course, Carlo Rovelli needs no introduction, philosopher of physics, physicist, and acclaimed writer who writes and is invested deeply in sort of the public understanding of science. So absolutely delighted to give the floor over to the two of you. So Eric, did you had a few slides with which you—
Yeah, I thought I would just kind of review some of the key points of the talk, and along the way raise where I thought the most interesting points for discussing some questions were kind of integrate some of the questions that people asked yesterday and sort of maybe integrate them with my way of thinking about them, rephrase them in my way of thinking about them. Okay, so let me share my my PowerPoint here. Okay, great. So this is just Carlo's title, What is a cause and why does it happen before the effect? So just to kind of remind people of what the basic situation is here, right? The laws of physics don't seem to privilege a basic direction in time, but there's sort of at least three, maybe four key aspects of ordinary experience that do seem to privilege a direction of time. One is what you might just think of as the ordinary physical asymmetry in time, right? You know, we see ice melting in our cocktail glass and the water cooling as that happens. We don't see the water spontaneously warming and ejecting ice cubes. Eggs break, but they don't unbreak, right? So we just see, there are lots of phenomena that we see in the world that are time asymmetric. The second one is that I know a lot more about the past than I do about the future, and I know it with greater ease. If I want to know what the weather in Tampa was on February 28th, 1954, I can look at an old edition of the Tampa Times. But if I want to know what it's going to be February 28th, 2021, I need to make a forecast using basic physics. And if I want to know what it's going to be February 28th, 2054, I'm just out of luck. There's no way I'm going to know that. The third, and I'm going to try to say more carefully what this means, because I think this one's hard to state. I can influence the future, but not the past. That's kind of the key thing that Carlo's talk was about. But as I want to kind of point out, it's not exactly clear what we mean when we say that. And then there's actually kind of a fourth asymmetry that people sometimes talk about, and that's that I sometimes seem to care more about my future self than my past self. If you ask people, would you rather have had a headache yesterday than have one tomorrow? Most people would say, yes, I'd rather have it out of the way. I'd rather have had the headache yesterday than tomorrow. It's better to have bad things be in the past, and it's better to have good things in the future. So I seem to care more about my future self than my past self. So those are kind of four features of ordinary experience that are time asymmetric. And all of them, pose a little bit of a puzzle, given that the laws of physics themselves are time asymmetric. Okay, so what do we mean when we say that the laws of physics are time symmetric? Well, one way to think about it is by thinking about physics as living in kind of a state space. So the easiest way to think about this is if we just, and everything I'm going to say this is I'm going to assume kind of a really simple classical physics picture of the world, but nothing really hinges on that. It just kind of makes it a little bit simpler. So if you think of, a box of gas with a bunch of particles bouncing around, you can sort of mathematically represent that. If there's, n particles bouncing around, and each particle has three numbers that pick out its position and three numbers that pick out its velocity, then a 6 to the n dimensional space, kind of one point in that, completely describes that system. And what it is to say that the laws of physics are time symmetric is to say that what the laws really do is they pick out allowable paths through that space. And to say that they're time symmetric is just to say that anytime the laws allow a path going this way, they allow that same path going in the opposite direction. There's some slight infelicities in that, but none that really matter, right? Okay, so as Carlo pointed out, this has just been a feature of physical laws pretty much since Newton. We've had lots of different theories of what the physical world is like. They all seem to have this feature. They all seem to be time symmetric. They all seem to say, if something can happen at the microscopic level, then its time reverse can happen. That just seems to be kind of a non-starter to deny that for the last 400 years as we've been coming up with theories of physics. Okay, but again, right? Can I do this? Yeah. So we know, right, that our ordinary experience, right? This is a little YouTube video I found yesterday, right? This is the ad for a company that allows you to reverse your video. And when we see things happening, right, backwards, they strike us as strange, right? We immediately recognize that as something that does not happen in our ordinary experience, okay? So where does that come from, right? We know it can't come from the laws of physics. So if it comes from physics, it's got to come from somewhere else. And the answer is usually that it comes from something to do with the initial conditions, right? Because that's all there is. That's all physics has. It has laws and it has initial conditions. And once you give the laws and you give the initial conditions, physics basically says, you've picked out the whole world for me. Okay, but there's kind of a third thing that we need. And Carlo mentioned this a lot yesterday. That's this idea that we need a macro partition. That is, we need a way of carving up the possible way the world could be at the microscopic level into ways that are discernible to us, right? So that obviously there's lots, you could make very small changes in the microscopic physics of the world that I'm looking at right now, and I wouldn't notice them. So if you kind of carve the world up into the little bits of microscopic ways the world could be, and then put them into little bundles of ones that are indiscernible to me, you get this macro partition. And if it turns out, right, that the laws of physics basically bang you around in here as a kind of more or less random walk, and in the macro partition, the initial state that the universe started in is a very, very small one, then that kind of maybe can explain why, right, as the laws of physics bat us around in this macro partition, we go from smaller ones to bigger ones. And our brains are wired, right, when we see the egg reassembling itself, our brains are saying, wait a minute, you've moved from a big area in the macro partition to a small volume in the macro partition, and that ain't right? And that strikes us as bizarre, and we think that's weird, and it's not part of our ordinary experience. But, right, these three things together, right, some laws of physics, an initial condition that we start in, and this macro partition hopefully can explain, right, and this I think is pretty uncontroversial, that can explain why eggs break but they don't reassemble, why ice melts but it doesn't spontaneously form, etc. Okay, good. So that explains eggs, but what about the weather report? Why do we have records of the past but not records of the future? And I used to be kind of a little bit of a skeptic about whether this story could work. But it's actually Carlo's paper that I read just a few months ago. I forget what the title was. It's the one we read it with the San Diego reading group. It's a really, really nice paper where I think he really nicely explains how the statistical mechanical asymmetry I just talked about gives you the temporal asymmetry of records. And the idea is just this, right? That like if you have nice, smooth, sort of low entropy devices kind of sitting here, right? Like a nice calm pond, and you throw some other sort of, low entropy thing, and they collide with each other, you get a disturbance in that kind of can persist for a while. And I'm not doing this justice, but he has a really nice paper. I think he lays out all the details of this in a way that I actually found rather convincing, even though I'd sort of maybe previously been a little bit of a skeptic of this. Okay. So that's how we get out of just the asymmetry in the initial conditions plus this macro prediction. That's how we get maybe, and I've become more and more convinced of this. That's how we get the existence of records about the past, but no records of the future. Okay, so that seems nice, right? Even though the laws of physics are time reversible, a nice coarse graining on the initial conditions would explain why we have records of the past, but not the future. Okay, but notice, if we want both of these things, either one of them really, right? If we want to explain why eggs don't unbreak, and we want to explain why they're records, we need not just the right laws and the right coarse grain, we need a harmony between the dynamical laws and the coarse grain that does all the work, right? Some laws on initial conditions with different coarse grainings won't forbid eggs from unbreaking, and some coarse grainings won't forbid eggs from unbreaking with different laws, okay? And fundamental physics is completely ignorant of the coarse graining, right? The coarse graining is not a feature of fundamental physics. So where does the coarse graining come from? Well, it comes from us, right? And so here I want to remind people of a question that Brian Campbell Smith asked yesterday. He asked, right, I hear you saying that biology and culture require low entropy macro variables. This is how, why, where we developed. Could it be instead that we are more responsible for the low entropy macroscopic processes than we use as a consequence? Could it be that we humans coarse grain the world in ways that parcel it up in low entropy ways? And Carlo's answer was, well, yes, both, right? We do coarse grain it, but not by choice, right? It's not a choice of ours to coarse grain it. It's something about the basic way that we're put together, right? I mean, here's my way of thinking about it, right? It's hard to imagine, I would think, creatures whose stabilizing properties and information processing abilities and reproductive abilities, et cetera, are realized, right, with the kind of biochemistry and the kind of neurophysics and the kind of, the basic kind of way in which we're engineered, right? It's hard to imagine creatures like us who didn't have our coarse graining, okay? So if the direction of time is tied to causation and causation is tied to agency, we might want to ask, like, what is required for agency, and is agency fundamentally tied to our coarse graining? And there are a couple of questions we could ask here that I think are really interesting. One is like, could there be agents whose coarse graining is such that what we call the final state of the universe is very low entropy to them, and therefore are kind of zooming by us in the opposite causal direction? Of course, we would never see these guys, right? But is that possible, right? Or is it just impossible to imagine creatures who do anything remotely like information processing and reproduction and whatever else we would think would make them creatures without having the same coarse graining as us? That's, I think, something that's sort of probably hard to answer, but interesting to speculate about. And this is, I think, another question that I was wondering about during Carlo's talk yesterday. So it's really, I've thought about this question of where coarse graining comes from for a long time. And there's sort of two different ways of thinking about it, right? What is it about us that coarse grain? So if you take like an introductory statistical mechanics book, right? It'll say what the coarse graining is. It'll say something like, it's a coarse graining of the universe into states that are equal with respect to certain microscopic variables, like, and usually they mention things like temperature, pressure, magnetization, things like that. Those are usually the macroscopic variables that we think of as coarse graining when we're doing physics rather than like philosophy or whatever. So one thing I've always wondered about is, does my coarse graining come from my observational capacities, or does it come from my interventional capacities? Or is it some complicated mixture of the two? And if it fundamentally involves my interventional capacities, is there something a little bit circular about the whole story now? So, you know, I tend to think of like, well, what the history of statistical mechanics is, right? It starts with thermodynamics. And thermodynamics was a control theory. Thermodynamics was the theory which said, here are the things that you, if you want to be an engineer that's building steam engines, here are the things you can do. Here are the kinds of interventions that you can make in the world. And here are the ones that are impossible, right? But they're impossible not because microphysics forbids them. They're impossible because of the kind of creature that you are with big fat fingers, right? So it's almost sometimes I think like the coarse graining comes not just from what I can discern observationally, but what causal handles I have on the world. And if that's right, my spider sense starts to tingle now that maybe something circular is going on here. And I'm not really sure if I think that or not, but I'd like to explore that idea, or at least hear Carlo's story about why that shouldn't be a worry. Okay.
Eric, I have a quick question.
Yes, please.
So, in this particular case, is this a claim that evolution maybe selects for this? So there's like a thermodynamic selection? I mean, are you?
Well, look, the idea is this goes back to Maxwell's demon, right? So Maxwell, James Clerk Maxwell, one of the founders of statistical mechanics, pointed out, right, that if you had a little guy who was small enough that he could see every little bouncing particle in a box of gas, and he could open and close a shutter, right in response to them, he could cause anti-thermodynamic behavior to happen, okay? So the fact that we can't bring about anti-thermodynamic behavior has to do with the difference between us and Maxwell's demon. And that difference is something like that my fingers are too fat, right? I can't operate little shutters that small.
Fast enough.
I can't fast enough, quickly enough, responsively enough to micro conditions. What my interventions on the world are, they're bruter and coarser than that. And that's kind of what picks out the coarse graining. And it's kind of, Carlo used this expression, subtle dance between two things a lot yesterday. And I feel like there's something going on here in the macro partition, which is people often talk about it having to do with our observational capacities, but I think it's kind of the result of a subtle dance between our observational and our interventional capacities. And I kind of like to see if we can talk about that a little bit at some point today, because I think it's kind of interesting. Okay, another thing that I kind of would sort of notice in the talk yesterday is that, Carlo, you used a couple of quite different characterizations of agency. Early in the talk, you talked about agency as just kind of anything counts as an agent if I can bracket it off and it sort of affects what's an otherwise closed system. So if I can divide the universe into two halves and consider one half of it closed, and then something comes from over in this half and comes in and bounces it, like a meteorite or something like that, that can count as agency. But I guess I feel like that's not quite right. And I feel like later in the talk, you said things that I think are more right about what agency is. Agents are the kinds of entities that collect information, deliberate about what they want the future to be like, and move themselves around in the world some way or other so as to bring about things that they prefer.
Right, so there's intentionality.
There's some intentionality, there's some information processing, There's some deliberation. There's stuff like that. So, and one way of thinking about why I don't think that the first characterization of agency works is we do talk about sort of, meteorites coming in and causing craters. We do this, but I think that's parasitic on the causal ordering that we've already imposed on the world that comes from our deliberation and agency. I don't think if microscopic Laplacian demons came to our world and there were no people in it, they wouldn't think that incoming meteorites and outgoing volcanic eruptions were interestingly different. There'd be no asymmetry there. The asymmetry, I think, only comes when we have deliberative agents. The causal asymmetry, right, I think only happens when we have deliberative agents. Or if not, I'd kind of like to hear more about why I shouldn't think that, because that's my inclination. Okay, so what is agency, right? To me, agency is fundamentally tied to deliberation, which means it's tied to information gathering, information processing, it's tied to preferences, and it's tied to integrating all those abilities so as to bring about preferences, okay? So when I talked about the third asymmetry at the beginning, I said it's that we can change the future but not the past, but that's of course wrong, right? We've known sort of since David Hume, right, that, well, we have to understand agency in harmony with determinism, right? We have to understand that it's possible to have agential beings in a deterministic world. And in a deterministic world, I can't change the future any more than I can change the past. But I still deliberate about it. And it's a puzzling fact. It's a puzzling fact, but it's one you have to swallow, right? So it's not that causes precede effects. That's a reasonable first pass at what the asymmetry is. But I don't think it's exactly what the asymmetry is. I think the asymmetry is that, and it's not that we can influence the future, but not the past, right? So the problem with the first characterization is it's non-agential, and there's no non-agential characterization of the third asymmetry. The problem with the second characterization is it doesn't respect, the insights of compatibilism, that we have to understand deliberation alongside determinism. Right? So I think the real third asymmetry is this. It's that we, on pain of insanity, right? On pain of insanity, we deliberate about how we want to make the world be in the future. We do not deliberate about how we want the world to be in the past when we make decisions, okay? If you saw someone standing at a lever, trying to decide whether to put the lever to the right or to the left, and you said, what are you doing? What are you trying to figure out? What are you deciding on the basis of? And the person said, I want the world to be in such and such a way in the future. And I'm trying to figure out which side this lever goes is more likely to bring about the future than I want. We'd say, yeah, that's cool. That's a normal thing. You're a normal person. If they said that about the past, we'd call them men with white coats, right? Why? I think that's the asymmetry. This is what Hugh Price has called the temporal asymmetry of disjunctive deliberation. Nice fancy word for that. Okay. So agency, right? I'm putting up the trolley problem here, not because I'm going to start talking about ethics, right? But here's the famous Philippa Foot trolley problem. Should I push the fat man in front of the trolley to save the 5 people? Right? That's a perfectly sensible question. But should I push the fat man on the trolley to prevent? So maybe you tell me, hey, you know what, Eric? Someone is predicting whether you're going to push the fat man onto the tracks. And if he predicts that you're going to push him on the tracks, he's going to kill 5 people. Your mind recoils at this whole scenario, and you end up in Newcomb's paradox, and you end up in all kinds of strange things because we just think it's absurd when we're thinking of ourselves as agents, when we're deliberating about what actions to take. We think it's absurd to worry about how they're going to make the past be. Okay. Now, it's absolutely right. It's absolutely right that you can solve this problem. This problem goes away. This problem stops being a problem. It stops being a puzzle if you can explain the sense in which the future is open and the past is closed. Because if the past is closed, then of course I don't deliberate about how to change it. Okay, but here's the $64 $64,000 question, I think, about yesterday's talk. Does the existence of records sufficiently close the past and open the future to explain the sense in why it's insane to deliberate about changing the past? And Carl, I see Carlo shaking his head, which worries me, because I think that's what we need. If we really want to understand, if we really want to solve the main puzzle of asymmetry about causation, it's this. Why do I not deliberate about how I want the past to be? And, so does the existence of records, I was basically doing the slide, right? Does the existence of records secure the relevant notions of the past and future being respectively closed and open, okay? And there were, I think, a couple of questions from the audience yesterday that were pressing on this. So Peter Morgan asked, right, my Zoom thing gets up in the way. Here we go. The past is only fixed insofar as traces persist. Is it only that the creation of traces is relatively fast, the decay of traces is slower, that if we burn evidence is gone, right? So the worry here is, right, that there are lots of things about the past, right, that we don't have traces of.
Yeah.
There's a lot about the past that's open.
Exactly.
Why don't I deliberate about how to make that different?
Exactly.
Right? And so Parikh also asked, right, if two people are observing the same traces, might make different inferences about the past. We assume that one is right and the other is wrong. Okay, but if the closedness of the past is about the inferences I can make from records, something weird's going on, right? That's a shaky notion of closed. It's a very epistemic notion of the past being closed, and it might be closed for me and open for you. So you might think it's insane for me to deliberate how the past is be because you believe, right? Like maybe I'm trying to kill baby Hitler, and you think you have a picture of baby Hitler, so you think I'm insane. And I say, no, that picture of baby Hitler is blurry. I think maybe the past about whether there's a baby Hitler is still open or not. I mean, that seems like a weird thing for the insanity of me trying to bring it about, not by time travel, but just by intervening on the present, trying to kill baby Hitler. Whether that's insane or not, depending on whether the picture of baby Hitler is blurry or not, seems weird. Okay, I think I'm getting close to the end. Yeah, so the existence of records doesn't seem like it's enough to prevent me from deliberating about how I want the past to be, both because records are limited and because records are uncertain. Okay, so thanks, Carlo. Thanks for your talk yesterday. Super interesting, super thought-provoking. Those are some of my questions.
Thank you, Eric. That was fantastic. Love your slides. Wonderful. And I think we are waiting to hear back from Carlo about, I think, a lot of intriguing questions that you have raised. And I think some of these questions are quite profound, I have to say. So I'm really looking forward to what Carlo has to respond.
Thank you, Priya. Thank you, Eric. I have been taking notes furiously while you were talking. Let me anticipate a couple of things before trying to answer. First of all, I'm very happy of what you have done. These are subtle issues, of course, and I often find myself discussing with people that have a lot of different assumptions, and it's difficult to start organizing the common ground. That's not the case at all in what I heard you saying now. I mean, I know a little bit of your work. Well, I think I agree with everything you say. I mean, we are on the same ground. We agree on the problems. We agree on the situation. So I'm entirely with you with everything. And you have raised two problems. In fact, not really two challenges, but two points in which you say, wait, there is a there seems to be missing something here. And they're both crucial. I think I have some understanding about both, and I'm happy to try it on you. And I think we do have sufficient ground, maybe not in a half an hour. If we had a couple of days and 2 armchairs, maybe a blackboard, I think we could totally communicate on that. But let me try. And I'm hesitant of doing both because the second is more interesting in a sense.
Yeah, I think the second is definitely more interesting. Yeah.
Yeah, but let me say something about the first, and then you tell me if you want to stay on that go on the first. So the first one was about a possible circularity in let me put it in a bit over sketchy manner in the definition of thermodynamics, the definition of macroscopic quantities. What are the macroscopic quantities that somehow, in terms of which we make sense of reversibility and irreversibility? And I am 100% with you that the clarity about thermodynamics is about how we manipulate things. And in spite of, I'm 100% with you that in spite of a huge literature on that in various positions, Maxwell had it clear. Namely, thermodynamics is about a thermodynamic system on which we do something, and we have a finite number of things we're doing, and thermodynamics is theory that tell us what happens if I do this, and what happens if I do that. So there's a notion of manipulability, which is the one that defines the coarse graining, because the macroscopic quantities are the ones on which I intervene or not. This brings complete clarity to the structure of thermodynamics itself. What is missing is not anything related to myself. What is missing is that, all right, so who is the manipulator, and how do we think in terms of manipulator if we want to make a step further and say, well, I'm a naturalist. I don't think there are, demons outside nature or us outside nature, but there are natural systems that are us manipulating, and demons are natural systems. And nowadays in laboratories, you can do little Maxwell demon things with molecules, and these are natural systems. So then one possibility is just to take the notion of manipulation as primitive, and another is try to see how it concretely it's realized by the manipulator as a physical system. And I think that here there is a step that we can make, and I've been insisting on that step. Namely, we don't need manipulation. We may have a simpler, a more wider way of saying exactly the same thing. Namely, instead of thinking thermodynamics, if I do this, that's what happened. We can say, and it's equally, if there is an external system that happened to interact in this way, that's what's going to happen. If so, what determines the coarse graining, it's an actual dynamical interaction between the system and the manipulator, the observer. In other words, as a naturalist, I want to think of both of them as described in physical terms. And again, as you did, forget quantum mechanics, everything, that's just classical. So if you want, there is a Hamiltonian. The Hamiltonian, it has an interaction terms. This interaction term is an interaction with some variables of the system, not all of them. Good, it is. That Hamiltonian picks up some variables. And to the extent in which I'm describing the interaction of the system with something else, the observer, the demon, that only interact with that Hamiltonian, with that variable, what happens is well described by the thermodynamics with those coarse graining. So I've not.
Yeah, that seems good. I mean, if you can just describe what is the coupling between the
Exactly.
some other system, then
Exactly.
you don't really have to think that much about what my interventions are,
Exactly.
because obviously my interventions are going to be parasitic on what my couplings are.
Exactly. And this allows, so the price of this is that we don't have an a priori thermodynamic dependent on which system is interacting how. Fine, I buy that, and I don't think at this point there is any circularity. That's fair. That's
pretty satisfying to me.
Address your first question.
Yeah. Okay. Let's move on. Yeah. Let's move. I do think the second question is deeper and more interesting.
Yeah. Which is the interesting one. Is about agency and deliberation. And look, I follow carefully what you're saying, and agree with everything. At some point, you say, "Wait a minute. What do you mean by agent?" And at this point, we don't want to go into an issue of names, of course. It is a fact that we use agent in a different, to indicate different things. And there is, so we can say agent one, agent two, agent three, whatever. I mean, we can give different names to things. So there's one definition of agent, which is too wild. It's not the one you like, but it can be found in the literature, which is very weak. I'm going to the next one. I'm going to the other one in a moment. But the weak one is simply, it depends on at its turn, it depends on an approximate description of a situation. So it depends on a certain number of variables, which are related by some relations between them. For instance, macroscopic, for instance, the solar system dynamics, Newtonian dynamics, and I want to call agents everything which is exogenous to that and interact with that at some point.
So just really quick, right? I mean, you're absolutely right. That nothing hangs on what the dictionary definition of agent is or anything like that.
Right.
But what hangs on is which notion of agency underpins a temporal asymmetry, right?
Yeah. It's clear. Okay. It's completely clear that this is. And then you're saying, wait a minute. When we talk about agency, that when temporal symmetry comes in, there's more. There's a notion of deliberation. Okay. Now, there's no doubt that there are very special agents that deliberate. Okay. Even those are very different kinds, because the thermostat of my apartment fits quite many of the characterization of the deliberator that you gave. The rover, which is on Mars, which independently decides that there is a sandstorm arriving, so it shuts its head down. It has a purpose, which is to preserve itself, which is written in its software. So it's a deliberator in some sense. Why? And in fact, the rover on Mars is a good example, because sometimes it decides by itself, sometimes it doesn't, because we govern it from, and we use this language regularly, okay? Take away its freedom and, and now we control it. No, let it decide by itself, okay? We do understand exactly the physics of the rover on Mars, or we pretend to be able to understand. We might be, and this is a huge can of worms, but I think we might take the stance that we could use exactly the same logic for understanding humans. Namely, a lot of things happening in our mind. Some of this we describe as deliberation, the same ones as we use deliberation. Now, let me zoom into the point. What is it in the physics of those systems that we call agent that specifically has to do with the difference between the past and the future? And I think is not, it's nothing to do directly with traces. It's a different story. And it is the fact that it's the same logic as the traces, but it's a very different story. So it's the fact that there's a system that have a characteristic that it can be fully described in some approximation. Okay, so disregarding something which we may change, but in this approximation, the history in this approximation can be the same in the past and different in the future. So this is why, because of second principle thermodynamics, because they are.
Can you run that last claim by me real quick one more time? I didn't quite catch that. I don't think it's so that
I want to call agent in some intermediate sense between.
Yeah, that's fine. So we're talking about the rover on Mars, and the claim was just that
as a system that has internal behavior somehow, which
on some approximation. So it's a coarse graining of the rover into its causally relevant variables or whatever. Yeah.
Right. In this approximation.
Yeah.
I have information about its dynamics. I can predict its dynamic.
Right.
But at some point, my prediction allows a splitting toward the future, but not toward the past.
Yeah. Why though? Where does that come from?
I want to claim that
precisely. Why is that?
Yeah, that's my second paper, not the one on traces, the one on agency. I want to claim that precisely in a similar manner in which the second law of thermodynamics plus system separations plus long-term realization time naturally produces traces, in exactly the same technique, this happens. This kind of things happen. And if you want to think how, you have microscopic degrees of freedom that you don't know, but if they can act on macroscopic degrees of freedom, you don't know on which one they're going to happen. So that's a thermodynamic description of a split of a micro evolution in the future.
I said just really quick. So David Albert's story, right, goes first I get records and then I leverage records into an open future and a closed past. You're not doing that. You're getting records and open future. Or you're getting sorry. I mean, sir. Let me rephrase that. In David's story, you get records. That gets you, an open future, and that explains the asymmetry in my deliberative capacities. You just want to tell a similar story that underpins them independently. Is that right? Okay.
Yes, and the reason
I didn't get that yesterday at all. Okay, good.
And the reason is exactly the one that you were mentioning. Namely, I spent a long time telling myself, look, we have a record, therefore we have the past, the future open, but it doesn't work. No, I mean, it's too weak, and it's too weak for the same reasons that you were saying. I mean, we don't have full records. If we had full records, perhaps this could work, but we don't fully records. So it's exactly the same story. I mean, I don't have a picture of Hitler young, so does it mean that I can deliberate about it? No, it should be something else that generates the systems that allows the system that we call agents, and on what can it be granted? I mean, if not from something extra natural that comes in, only on the second law of thermodynamics. And I think that in my second paper, I tried to model that. So deliberation is just one particular case. Deliberation is something that happens. Let me say one thing about deliberation. Either we can open up exactly the mechanism of deliberation. I can work up exactly the mechanism of my thermostat when it decides to, okay? And then I realize that the time orientation is fake. It doesn't really, I mean, it's really time symmetric. Or there's a deliberation and I treat it as free, okay? Which I can, because we always do in life. This is allowed by the second principle of dynamics. Not only is allowed, but is implemented at the second principle of dynamics precisely because if you have system segregation, when energy goes from the hot to the cold, the cold can have macroscopic variables that now evolve differently. So this is the information that goes from entropy to macroscopic. So in other words, I see exactly the problems that you're pointing out. And I think that a careful sort of physicist discussion of how is it possible that there are these deciding systems. So what happened for real in a physical system that we naturally describe as a decider clarifies that is nothing else than standard thermodynamics that indeed put the system in those systems are such that we naturally describe them as what happened inside them affect the future and not the past. Once the system exists, the rest is psychology. So of course, now we are one of this system, and now we want to decide the past, and now we have aims, we have desires, we have an evolution, we have information, we have language. But that's once you have opened up the fact that there are systems that can determine the future, not the past, then you have to, of course, to understand how a human beings works is a much bigger problem.
Sure. Okay. Yeah. No. I'd love to see the details of that. I'd just have to take a look at that paper. I haven't looked at it.
But I you know, while you were talking, I was, in fact, not only agreeing with you, but recognizing the same puzzling I went through. I had a lot of discussion with David Albert that you were mentioning,
Yeah.
and yes, of course, the existence of the past of traces is a major reason for us to consider the future fixed, but it's not sufficient as a region for considering the possibility that we can act on the future in a sense. So we need to restart again from the second principle of dynamics and build understanding that. So I agree with you.
So at this point, you know, I have this question, maybe quite, and I would like to hear both of you. So how do we reconcile this with this whole idea of the sum over histories for going from, so you can go from the past to the present and the present to the future. And in sort of Feynman's idea of these sort of, you know, sum over all these possible histories, I mean, is that just then a natural way to link? I mean, is time embedded in this, or is this just a way to marginalize over, you know, probabilities to distinguish it from sort of a deterministic path? I mean, is time intrinsic to this? So this is something that I'm trying to understand. But, you know, it may be a naive question, but I'd like to hear your take on that.
You want to start, Eric, or should I?
Well, so I mean, when people ask whether time is intrinsic, one thing one wants to be super clear about is, do you mean the existence of the ordering? In other words, does the fact that time is a parameter in all of our physical theories, is that fundamental? Or do you mean, is the orientation of the past and the future fundamental, right? Yes. And it's, I think, pretty clearly in Carlo's story, and I don't know what his views on this are, but it's perfectly comfortable with thinking that time in the first sense is fundamental, but not comfortable at all with time in the second sense being fundamental, right? But yeah, so you were asking about, were you asking about it in the first sense or the second sense, Priya?
I guess I was asking about the first sense.
Oh, the first sense.
Yeah. And because, I mean, you know, Carlo has talked about theories and theoretical ideas in which time need not appear as a parameter at all, right?
Right, but this is a, yeah, right. So the two separate questions. One is a question about the orientation.
Right.
Let me say a word about that, just to put it out of the way. There is indeed a discussion in quantum mechanics, but I'm much convinced. In fact, I just have a paper out on that, in which the discussion about non-relativistic quantum mechanics, say, it just like the classical one. It doesn't change anything to what we've been saying so far. Maybe quantum mechanics is also invariant in the time reversal. In fact, I had a lot of discussions with various people, and with Andrea Di Biagio and Pietro Donà, we wrote a very detailed paper arguing that, and we got 3 wonderful referees report, very, very detailed, with a lot of, which basically said all 3, but we knew that already. And I agree. I mean, in spite of some discussion, I think that as far as the orientation of time is concerned, the quantum mechanics does not change anything. Right. Now, the first issue, as Eric was saying, the existence of a parameter that in terms of which you order the event of the universe has not. I haven't touched any of that in this discussion at all, and I think it's a separate issue because when we talk about thermodynamics, we're always thinking in a context in which we have a time parameter. So we learn from general relativity that the world it's more complicated than just a single time evolving. Okay, I mean one can use a cosmological time, and cosmological time is an average in a sense. It's not a so it's definitely when one goes to general relativity, and even more when one goes to quantum gravity, one needs a wider notion of temporality, which we're not going into it now. And I am convinced that we do not yet have a clean or even a vague, in fact, understanding of thermodynamics in this wider context. So, in fact, I consider one of the open problems of fundamental science. We really don't have a general relativistic thermodynamics, not only in the quantum domain, but even in the classical domain. We have thermodynamics on a given curved space-time that was worked out by Tolman back in the 50s, I guess. But the thermodynamics in a fully thermodynamics of space-time, so to say, it's still very much in the air. So asking questions about what is the second law of dynamics, what is entropy, when we fold in the possibility of statistical distribution of geometries, it's something which there's very little clarity right now in my head, and I think in many people's head.
Thank you. So,
but in a sense, the 2 things are related, because if causation is fundamental, which was the original thing, and if there's a fundamental arrow of time that determines causation, which is that, and if it cannot be traced to just macroscopic description of things, then we will be in trouble to understand general relativity, I think, to understand quantum gravity, because we need even the vaguest possibility of thinking in this.
So I just wanted to open up now, and Peter Morgan, did you want to ask your question?
I can certainly,
yeah.
If you can hear me, that is, can put the comment I put up here, that is, can we use an analogy with transistors?
Right.
For which the whole point is that you have a control input as well as the in and the out. And in many ways—
Get a stool and take it out.
Oh, sorry.
No, sorry, there's just some background, yeah.
So it does feel as if often we try to leverage our position. We think to ourselves, oh, well, if I do this, then I can have £1 million in my bank account, and that's better than doing some other action that will just result in $1 in our bank account. And so the very smallest of impulses in our brain results in a really relatively large change. And so you're always trying to leverage. And in some ways, I mean, there's the old sort of gnats and smaller gnats all the way down, so to speak, but at least over a few scales. So, oh, okay, well, here I am. Hello.
Oh. Can I ask you, I missed one word because of the sound, but it was a key word. You started by saying, can we use the analogy with?
Transistors.
Oh, transistors.
Yes. So with three, and really also an analogy with leverage in the simple mechanical way, just that we always are working to result in a bigger change as a result of something small. In our minds, typically in the beginning, you have a sense of an idea forming, and then becoming a motion of your muscles, becoming a motion of something else. So always getting bigger and bigger and bigger. And then some of those things become actual traces, and some of them just disappear into nothing. You think to yourself, I'm going to make a big change by making this intervention, and actually nothing happens. And other times you think to yourself, I'm going to make almost no change by making this other intervention, of course, and sometimes that becomes something huge. So
yeah,
always
is the idea that somehow this ability to cascade small into big is thermodynamic? Well,
in the sense that anything, there are flows of energy and of chemicals. So there's not just, after all, thermodynamics is not just about energy, it's also about chemical potentials and so on. Indeed, one has different chemical potential for every possible chemical there is, which is enormous. And so we will leverage something like a particular oil or a particular chemical. So benzene has a very different value in society than does chloroform or whatever it may be. And we seek to change the flows of all these things separately. We try to separate the flow of something that starts off as a mixture of benzene and chloroform as part of just fuel oil or whatever, straight out of the ground. We try to separate that out into different, by fractionation or whatever other chemical or physical means. And always, it's some engineer somewhere has thought to themselves, hey, if I just do this, I can have this huge, great effect on the world. And my bank account is better because of it. Or for whatever motivation, of course. I mean, people certainly don't want to say just dollars. But at the same time, resources of all different kinds. Indeed, the dollar, the abstract dollar, in a way, it has its own chemical potential. It's something really quite complex, that nonetheless is rooted in the real world, if not in gold. So, sorry, I've gone on.
Yes, Peter, I think I see what you're at, and I think I buy the analogy, because somehow what you're saying, we study physics and we start everything being linear, so small things produce small things, big things big things, and then of course as soon as we go to more complicated things, we discover that's not the way the world works. The work is not linear at all. So there are big things that evolve into nothing, and there are small things that has huge effect. And the entire transistor is based on this idea that you have one pin that determines the two big ones, which one is and yes, that's exactly the point, it seemed to me. So if you not only think in terms of big and small, but you say you think that the big is what, the small is what you did not control and you did not know, and the big is what you see, then you see a decider, something splitting the future. From a situation which, of course, the physics of a transistor is time reversal invariant, obviously, but if you fold in dissipation. So the little model that I had about traces, it's like a transistor, right? Because I had some macroscopic penduli interacting with those small little things of which I did not have control. And once in a while, this is the point, our intuition about thermodynamics is always toward the equilibrium. Or we say, oh, there's non-equilibrium thermodynamics, very complicated. But there's this thing in between. When you have system separation, and both systems want to go to equilibrium, but there is a long thermalization time, in which is part of thermodynamics we understand very well. And here it's exactly the same situation, because if the interaction is a little rare, once a hot particle excites a macroscopic pendulum, you have a small effect creating something that enters into the part that you call macroscopic. So for you have a trace, and you can use something similar to model deliberation, okay? Because you don't know what is happening, but you know the coming out of the result. So it is leverage, what, in the sense that you were saying, that create traces, little few photons into the camera create a picture that allows us to know whether Hitler existed or not existed, was in Vienna or in Berlin. So I see the analogy, and the key point being that is scale separation and nonlinearity and the big effect of small causes that ground all this phenomenology that then we interpret as traces or agency. I don't know if one can do more than this analogy. I can use that more explicitly. I don't know.
Great. Thanks. Anyone else from the audience have any questions? Please feel free to type up in the chat, or let me know and we can unmute. And
Carlo, I had one sort of minor question from yesterday.
please go ahead. Yeah.
Which was I was interested in your claim that that all of Aristotle's causes are have the time asymmetry that we associate with our modern notion of cause. I thought that was a somewhat surprising claim, particularly about final causes. Why do you think final causes for Aristotle have the ordinary time orientation?
Because of that, yeah, it's good that you raise that. Because my first thing, I'll tell you what I thought about that. My first train of thought was, wait a minute, it's not true that that the cause precedes the effect. We use final causes all the time. I mean,
he calls them final causes precisely because he thinks that the thing at the end of the temporal chain is the cause.
Yeah, I mean, that's Aristotle's notion of final causes, but it's a notion that we use. It's not a notion that he emphasizes it. I put the cause for which you put money in the bank is for the education of your children. So the cause is in the future, it's the education of your children. Not the cause I take the umbrella is because tomorrow is going to rain. So it's tomorrow's rain the cause of my umbrella. So we use the notion of final causes all the time, right? And then you say, okay, so therefore causes are not time-oriented, and the final causes are just a reversal of efficient causes in Aristotle language. So efficient causes is when I put the cause in the past, and when I do the other way around, it's final causes, the cause in the future. But that's not true, because final causes are not the time reversal of efficient causes at all. They're different beasts, completely different beasts. So therefore, and I can, we can go in exactly what Aristotle means by causal causes, or what we mean by causal causes. So in other words, both the efficient causes and the final causes have a time orientation. They both require to distinguish the past from the future. And of course, we usually can retrace the fact. That's what we usually do in our mentality. We retrace the final causes into efficient causes.
But we do that, but of course Aristotle didn't. Aristotle thought final causes were really fundamental causal building blocks of the universe, right? Yeah. So Aristotle thought there really was causation from ends to beginnings, which we think when you say, when you say I put the money in my bank account so as to send my children to college, we can reconstruct that so that it's really just efficient cause, right? It's, well, you had the belief that, it's really just that you had the belief that putting money in the bank would, and it's the belief that causes the putting in money in, not the end. But Aristotle thought, no, really final causes really do bring about states of affairs.
Oh yeah,
So,
yeah. No, sure.
Yeah.
So what I would argue is that from our understanding of causes.
Okay.
Time. No, yeah. Final causes in Aristotle are very. It's really striking because he was a biologist as a scientist mostly, and so there's a page in his biology which I find completely striking. He says, "Look, you can think at causation from the future in biology in evolutionary terms, because there had been Empedocles with his idea of essentially of Darwinian selection, right? Thinks we have the cats have the right number of legs because those without the right number of legs die because they cannot survive. And Aristotle has a very interesting point. He said that's a great idea, but it does not work, because we don't see cats being born with an arbitrary number of legs, like he talks about cows. If we saw that, we would believe that. But no, they already are born. But then he says, but there are seeds. So he's sort of suggesting it could happen that not the individual cats, but the entire family of cats survives because of natural selection. So it's just there. And then say, okay, now what you're going to say. And he says, well, but I'm not doing history here. I'm doing the world as it is.
Right.
And to understand the world as it is, final causes work.
Right.
So it's Aristotle's.
He's almost there. Yeah.
It's unbelievable clarity.
Right.
Yes.
Yeah, I think we have some questions in the chat. Do you want to?
Yeah, so I think Gary,
Yes. Does your theory imply a completely determinate universe, as Spinoza believed?
Good. No, the answer is no. First of all, I hesitate to say what I presented as my theory. I think I put a couple of pieces in a puzzle, which is a number of ideas, most of which are not mine. But I try to then have an overall picture, including the little pieces I added. And I presented it in the context of classical mechanics, mostly, in which you can think deterministically. But I think that's obviously wrong, because the world seems to be non-deterministic, with a lot of caveat in the appropriate sense, because of quantum mechanics. So the present, what we can know about the present does not determine the future. But I believe that nothing changes, and everything can be said just with more complicated language in terms of probabilities. At the same step, I mean, I talk about Hume and David Lewis reformulating Hume causation in probabilistic terms. I think it can be done exactly the same thing, more in a more elaborated way. So there is no specific role for determinism in anything I said. But of course, it's not undeterminism toward the future. It's undeterminism equally toward the future and toward the past. So it's not that by itself undeterminism helps us at all to understand the orientation of time and the nature of causation.
Okay.
Not everybody agrees with them, with these ideas, because some people think that quantum mechanics is naturally sort of probability toward the future. But I don't see any evidence of that. Quantum mechanics it's naturally interpreted in a Humean sense. There are regularities. These regularities are not strict, are probabilistic, but they are regularities. And if I look at the regularity, they're time reversal invariant.
Thank you. Next, we have Tibor, who has a question.
Thank you. Can you hear me?
Yes.
Yeah.
Thank you. Excellent. Two thoughts that I've had prompted by what you, Carlo and Eric, have been saying. One of them is that it occurs to me that quantum mechanics may not be a theory on the ultimately fundamental basic level, on that elementary scale. It is itself a theory perhaps on some emergent scale. And the world being a complex system, which I think we all agree, means that the uncertainties, the unpredictabilities, the approximations that Carlo was talking about arise as a result of the complexity of this macroscopic scale, this sort of intermediate macroscopic scale, which is a quantum scale, rather than the world being fundamentally indeterministic. So maybe it's possible to accommodate the idea that the world is deterministic at the basic fundamental elementary scale, but it is indeterministic, or at least indeterminable, on some intermediate macroscopic scale, which is the quantum scale. And then there's another even greater scale, which is, of course, the scale where we live. Now, if that's the case, if that's possible, if that's a plausible idea, what I'd like to ask is it then possible to invoke the principle of least action as a characterization of causation on the elementary scale, on that very lowest bottom scale, where in a Buridan and perhaps Thomas Hobbesian kind of sense, things happen because they can, interactions arise just because they interact, the conservation laws hold, and everything seems to work down at that bottom scale and in a purely deterministic way. And then there may be an ordering by that, whether there's a temporal direction or not. I don't think that matters at that scale. All of that arises when we move to a somewhat higher level where we start talking about quantum mechanics. If we make that distinction, if we try and characterize quantum mechanics as being emergent, as perhaps, I think, is it Stephen Adler at Princeton who does that? He thinks that quantum mechanics is an emergent system. If we characterize it that way, does that help us to understand causation at different levels? We have a causation at the fundamental level, which is just the principle of least action, and we have a different notion of causation in the quantum scale.
Let me try to listen precisely to the various points you made. The first point you made is that could quantum mechanics be a manifestation of an underlying level where there is no undeterminism? The answer is yes, absolutely. And in fact, we know not one, but more than one theory where that realizes that. One is pile of weight de Broglie Bohm theory. It's a perfectly deterministic sort of metaphysically classical theory with equations of motions and no indeterminism whatsoever. Another way of doing the same thing is also many world interpretation of quantum mechanics, because that also deterministic. It's just the Schrödinger equation for the real thing being the wave function, and then a more complicated story connecting that to the observations of people don't like these options, not because they are incoherent or wrong. It's just because I don't like these options, because they don't seem to teach us more than what quantum mechanics teaches us. Namely, there is this invisible part of the world which we don't have access, according to the same theory, is outside our reach. We just cannot know it. So de facto, we have the same impossibility to predict the past and the future. in the many worlds because we're in a branch and we don't know about the other branches and so on and so forth. We don't know which branch we are, more precisely. So the first part is, yes, I mean, we could interpret quantum mechanics this way. But then you say, would that help us to understand something about causation better? I don't think so, because the question that was being debated is the time direction of causation. And all those theories are time reversal invariant. They don't distinguish past from the future in the appropriate sense. So even if we take quantum mechanics and and imagine that there is a actually real, whatever, underlying level in which there is, as you said, a principle for least action working, we're back to square one. Namely, we have a time reversal invariant fundamental description of what happens and no notion of causation, or time-oriented causation.
Okay, but that's, I understand that. But I think it was Eric who said that, or maybe you said it yesterday, that the time directional is itself an emergent property. At the bottom level, there is time reversal symmetry.
Yeah.
And I agree there would be. Any law that we made up using the principle of least action at the bottom level would be time reversal symmetric.
Yeah.
It's only at the emergent level, when we start getting feedback and more complex systems, that the asymmetry emerges. So we can understand causation at the time symmetric fundamental level as just an implementation of interactions, of just one thing happening after another, one thing causing another. We can have causation just as least actions and least interactions. We can have causation at that level. And causation would still be describable using time symmetrical laws, perhaps even despite the fact that the world itself is not time symmetric. It may be the case that there is a fundamental direction of time, that there is a case that where in every interaction there's a before and an after. And that it may be possible that that exists, but it is describable because all the actions are primitive, all the interactions are primitive. Every interaction at that level is describable using time symmetric laws. So maybe that our description of the world can be time symmetrical as a law, and our physics can be time symmetrical on that scale. And we can impose a time symmetrical description on something which is perhaps really time asymmetrical. I don't know, I don't think it makes a difference whether the world is time symmetric or time asymmetrical. And I'm talking about what the world perhaps, quote, really, unquote, is. I'm talking about the ontology here. It may be time asymmetric, it may be time symmetric, but we can describe both of these at that fundamental level with time symmetric laws, because our time symmetric laws cover apply in both directions. It's like the billiard balls on a table. You can just, there is a case that the balls were in one place and then you play the game and the balls end up in another place. And you could say there's a time asymmetry about that. But at every interaction, every collision between two balls, you can describe it using time symmetric laws. So I'm just wondering if it's not possible for us to impose time symmetry or to expect time symmetry, even perhaps when there isn't any.
I think a philosopher should address this better than me, but let me add as a philosopher, what would it mean to say that there is a fundamental real time asymmetry if we cannot describe it, we cannot perceive it, we cannot observe it, we cannot, if it is invisible, because everything we have experience about obeys time symmetric laws. So what's the point of saying? I mean, it wouldn't be like, yeah, I mean, everything is possible. There could be, you know, angels dancing on dragons in a parallel universe. It's possible, but what's the point? That's not what the world we have access to.
That's true. I guess for me, the point is simply trying to understand what I mean by causation.
No, but
Assuming a time symmetric world is no less visible, is no less observable than a time asymmetric one. The world that you describe and saying the world is fundamentally time symmetrical, well, we can't observe that either. So we don't gain anything from any of these things other than conceptually, other than as a tool for understanding what we're talking about. I think both of us, or all of us, are in theoretical physics. We're all talking about a world that no one can observe. We're looking for fundamental ways of modeling the world, out of which we can produce theories that derivative where our models can predict or describe the macroscopic world that we experience.
So look, I mean, there's a fundamental sense in which the world is obviously time asymmetric, right? I mean, it's, as the song says, starts in a hot, dense state, right? And it's going to end in anti-de Sitter space. So it's fundamentally asymmetric in various features of our experience, right? The question is just, I take it the question is just, the puzzle arises because at certain levels of description, namely particularly the macroscopic ones that are relevant to our experience, we see repeated patterns that are time asymmetric, right? There's a kind of, it seems as though there are macroscopic laws that are themselves time asymmetric. And the puzzle is, how do you get asymmetric laws out of merely an asymmetry in the initial conditions? There's manifestly an asymmetry in the initial conditions at every level of description, right? What's puzzling is that you can leverage, right? And this is what's so brilliant and fascinating and would be just wonderful if all the details came together. And I'm sort of always on the fence about whether I think it's happening or not. But what would be amazing, right, would be to be able to show that this one asymmetry merely in the initial conditions is then able to give rise to all of these asymmetric patterns. Not just that like the past is different than the future. Of course the past is different than the future, but that it's different in this repeated way that undergirds all of these seemingly law-like asymmetric features, right? That eggs never, it's not just that there's, you know, more broken eggs in the future than there are in the past. It's that eggs never unbreak, right? How can that come from just an asymmetry in the initial conditions? That seems like a magic trick, but it's one that people like Carlo are trying to pull off to show that it actually can go. I think that's what's going on here, right? It's not about whether there is or isn't an asymmetry or whatever. It's about whether an asymmetry in merely the initial conditions can give rise to all these beautiful, persistent, law-like patterned asymmetries in our ordinary experience.
So I think we have a lot of questions piling up in the chat. So I'd like us to move on to Rory. Did you want to ask your question, please?
Yeah, thanks. So my question's about just from the organizational side of going into it. So Leibniz in his discourse on metaphysics makes an argument for a world where God knows the future, and an argument that a kind of agency or free will exists. And so in order to do that, he makes a distinction between necessary truths, which logically the opposite is impossible, and certain truths or certain events. And so certain events, he says, are necessary ex hypothesi, which is after they happen. And so it's based on that, he says that at the moment in which we exist, the past is made up of all necessary truths, because they're ex hypothesi. The necessary truths and the contingent certain truths are now all necessary. But in the future, among possibilities, there are a limited number of possibilities because of necessary truth, which can be otherwise. But then one way things will happen is certain, because they can't happen more than one way in his organization. So is that a bad notion? Or are there, what problems are there maybe with that framework? And then also by that empirical, it's also an argument against determinism in a way, because looking at the past and seeing a cause, there's a cause for every possible event. So it could be a different way and you would also find a cause. So finding causes for the present doesn't mean that the future can only go one way.
I haven't studied Leibniz on free will, essentially, and the distinction between logical and certain. So I don't know. I should think about that. I'm puzzled because, of course, the problem obviously comes in that period, right? Spinoza is debating with the same thing, which is a completely different outcome. But the problem is much older. It has been debated through all the European Middle Ages, right? God knows the future. Nobody in text questions that. So what does it mean we are free? I mean, it's already in the mind of God what's going to happen next. And that's exactly the problem. It's exactly the same problem of the determinism. So I'm trying to navigate out of that. It seems to me that the specific solution on which we reasonably work is the one of Spinoza, not the one of Leibniz. Namely, we are confusing levels of description in which we know more and we know little. Microphysics and macrophysics, or in Spinoza terminology, we know what we wish, but we don't know the causes of what the causes, not in the sense we're saying now, the causes of that bring us to wish one thing or the other thing, to decide one thing or another thing. So the problem only comes if we take the perfectly legitimate notion of free will and decision and agency and arbitration and deliberation, which are all good ways of describing the world, and we reinterpret them metaphysically as denial to a possible, forget quantum mechanics, a possible underlying determinism. And we shouldn't. It's like, it's a common mistake that I think we do constantly, and confuses our mind. Right? When we, I have a preferred way, metaphor for saying that. If we think the sunset is the sun diving in the ocean, when we discover that the sun just stays there and is the earth spinning, it doesn't mean that there's no sunset anymore. There's still a sunset. It's just that the sunset is not what we thought, but it has all the properties that we wanted before. So if we discover that there's determinism in the world, it doesn't mean that there is no free will. It just means that free will is another thing than what we thought before.
Gotcha. I appreciate it. Yeah, that sounds very simple. Sorry.
Great. So I guess the next question we have from Seung-Gil Lee.
Yeah. Thank you. Thank you very much for both of you. So my question is how exactly we can get the causal asymmetry from the entropic asymmetry. I think the claim that we cannot influence the past is, if it's true at all, then would be true as a matter of physical necessity, right? It's not like it's terribly difficult to influence the past, but it's just impossible to do so if the claim is true at all. But the entropic asymmetry is probabilistic in nature. So I wonder how this strict causal asymmetry could arise from the probabilistic statistical asymmetry. The only way I can make sense of this reductive explanation for me is to think of causation as an epistemic sort of notion. I think Eric mentioned this briefly, something close to this. so changing the past would amount to changing our information about the past, or what we believe about the past, or something like that. Then it would be very difficult to change the past, but wouldn't be impossible per se. So is that the way we should understand causation, as it is supposed to be reduced to entropic arrow, or is there something else?
Can I jump out on this?
Yes.
Sure.
Yeah. So I think it's important to remember the following thing here about causation and about agency and about changing the future and changing the past. And I'm going to talk as if we live in a perfectly ordinary classical world, but I don't think quantum mechanics or relativity or anything changes this.
Okay.
We cannot, in the ordinary physical sense, we cannot change either the past or the future, right? Once the universe has its initial conditions and it has its laws, it will evolve as it will evolve, right? So the future is, in that sense, in terms of the fundamental physical description of the world, the future is just as fixed as the past, okay? So when we talk about our ability to change the future, but our inability to change the past, we gotta be quite subtle about what we mean by that. We don't wanna it's exactly like the sunset thing, right? I mean, there's still going to be a sunset, but it's not going to be what we thought it was in the 4th century or something like that. It's going to have to be something that respects the fact. I mean, at least if you're at all in any kind of sympathy with the way I think about the world, it's going to have to respect the fact that what's going on in our minds when we think about deliberating about how we want to bring about changes in the future has to be consistent with, this is what philosophers call compatibilism, has to be compatible with the understanding that this is all at the microscopic level, at the level of physical law. This is all unfolding in a way that's completely oblivious to my existence and doesn't care one whit about my deliberations, right? So when we talk about the inability to change the past, but the ability to change the future, we got to be really subtle about what that exactly means. And the best, Carlo might have a slightly different way of characterizing it than I do, but the way I like to think about it is, you got to think about what exactly is going on in deliberation, and about why it is that in deliberation we treat the future as open, right? It's not in any deep sense that the future really is more open than the past. It's that there's something about the nature of our agency that it makes sense to treat the future as open. And if you don't, I think, characterize the problem that way, you're going to give yourself fits, right? Because you're going to start thinking that, like, well, gee, what do you mean? Like, is it, if you make it seem unlikely that I could change the past, that seems wrong because it seems like it's necessary. No, you can't change if we're talking about things in terms of what are necessary truths given physical law, can't change the future or the past one iota, right? If we're talking about what underpins when I deliberate that I treat the future as open, then the fact that probabilism that's inherent in statistical mechanics comes into it might seem less puzzling than you made it out to be when you were treating it as if it's the past and the future that are really can be influenced by me in a deep, metaphysical sense or something like that.
No, point very well taken, Eric. Yeah.
Yeah, this is very good. That's a great answer. I think it's I agree with it. Can I try to add one thing? I'm trying to. So let me reformulate the question. The second law of thermodynamics is not an exact law. It's a probabilistic law. I mean, we can find a situation where it is, and in fact, we do find situations in the laboratory when we have a few number of things in which we violate what we would think the law of thermodynamics would say if we took it too seriously. And now the question is, if we can affect the future, not the past, because of the second law of thermodynamics. And since the second law of thermodynamics is approximative, then the fact that we can affect the future, not the past, is also approximative. So we might a little bit affect the past as well. That's the question. And I think Eric's answer is perfect. No, when you go to the regime where the second law of thermodynamics does not hold, for instance, a few number of degrees of freedom, is not that now you can affect the past and also the future, is that the meaning of affecting doesn't mean anything anymore. The meaning of I'm capable of affecting the future is something that has meaning only in terms of notions where the second law of thermodynamics holds.
Yeah.
Thank you. That was very clear. Thank you.
Yeah. So I'll read out two comments before we close with the final question. So Sudha Lakshmi has a comment about people with schizophrenia are known to have an abnormal sense of agency, and looking at their experiences has been a very fruitful way to think about the concept of agency itself. The main way in which their sense of agency seems different from the standard one has to do with where to draw the line between an agent and the rest of the system, sort of partitioning the world, right? How do you partition the world? And often people with schizophrenia attribute the actions of other agents or the behavior of the system itself to themselves, or the other way around. So it's kind of a partitioning error, if you will, right? So and she's just wondering if people have looked at whether the sense of agency that people with schizophrenia have includes the notion of temporal asymmetry. Is there some clue to temporal asymmetry there because of this kind of partitioning error? And I thought it was a very interesting comment. And if you guys had any thoughts on it, it would be wonderful to hear.
I mean, that is super interesting. It's I mean, a lot of I think maybe this is a little bit of a difference between me and Carlo. I really do tend to think of these of that third asymmetry in terms of our psychological properties, right? Of how we think about our agency. So yeah, I think it'd be really interesting to look at how other people. I suspect that two things. I sort of mildly suspect that schizophrenics don't have any differences with respect to the temporal asymmetry of their notion of agency. I strongly suspect that even if they do, the literature hasn't noticed this, because it doesn't seem like the kind of thing that the relevant people would pay attention to, but I don't know.
Yeah, so thank you. There's another comment, which is from Ferdoz, who is a friend of mine. And he said, he's kind of curious why we have not touched on Kant at all. And we have discussed Hume, Spinoza, Aristotle, well, the entire pantheon really, and Leibniz, but not Kant. And, the synthetic a priori judgments. And so
he thinks causes are just in your head. They're not in the world, so, right?
Yes.
Why would we? If you want to know what the origin of the causal asymmetry is for Kant, we impose it that way.
Yeah. Carlo, did you want to step in and say something, or I can then move to
no, I mean, let me say something a bit naive. Of course, you can be a Kantian, and of course it's fine, and of course, but then we are naturalists. So the my head in which the a priori are sitting, we want to. I mean, it's just this forms a priori of knowledge. We want to reinterpret them as actual, natural. The subject. It's part of nature in my philosophy. So it's fine, Kant, but it's just a half of the story. I want to know the other half of the story.
Yeah, it's not the complete story, right? Yes. So, okay, so I think we should, since it's getting on, we'll close with the final question from Cecilia. And her question is, hypothetically, let's say the past at the macro scale can change in accordance with a new future chosen by an agent from within the present moment, like the light cone model. And say this new correlation was an unconscious choice by said agent, then records of its previous past would exist as memories, Perhaps traces also exist in 3 dimensions as evidence. Seeing as the agent is, as Carlo believes, part of nature, nature would thus grant the agent's conscious choice to hold their memories as true, while also granting its unconscious choice for a new past or future correlation. Would this harmonious system grant both of the agent's requests, or would there be a dilemma? What could appear in the present moment to fulfill its desire while staying within the agent's realm of expectation? Interesting hypothetical.
I don't know. It's too complicated.
Yeah, it's a complicated.
Think about that, but it could be a novel, right? It's a science fiction novel of this story. I don't know. I'm not capable to answer. I don't know if Eric, you follow the story in detail.
No.
Okay, so great. I guess we wrap up here. Thank you, Eric and Carlo, for a wonderful discussion and for engaging this very sort of subtle, nuanced, complicated material and clarifying things for us. And thank you to everyone who attended and for all their wonderful questions. So very, very delighted, and we hope that you will all participate in this continuing series. And I just want to mention that the recording of yesterday's talk and today's conversation will both be available within a week. So if you want to listen to it again or pass the word and share it, please do. So thank you once again, Eric and Carlo, for sharing this Saturday afternoon with us.
Thanks for having us.
Yeah, that was a total treat. Really looking forward to this continuing conversation.
Extraordinarily interesting for me. Thank you, Eric. I think I'm gonna meditate on the points that you raised, especially the relevance of the complexity of the higher level of the agency role. So I look forward for the continuation of discussion also.
Yeah. Thank you. Thanks, everyone. Bye. Have a lovely rest of the weekend. Ciao.